Okay, ladies and gentlemen, good morning. So our previous lesson, we started to, started for this year. Again, you guys have done it in the past, but we started to look at the order of operations. Today we're going to take a look at them a little bit more deeply, specifically when we see parentheses, which we saw yesterday, but specifically when we see a number outside a group of parentheses. So let's take a look at number one. So I'm going to evaluate my powers simultaneously, right? So I've got this 7 plus 4 in the parentheses, so 7 plus 4 should give me 11 squared. Now really I know that 4 squared is going to be 16, and then 7 plus 16 is going to give me 23. So I'm doing this here, guys, because I'm a little bit short on space. When you guys do it in your notes, you would do it the way we typically did it in class, right? So this is going to give us 11 squared, which is 121, minus 23, which is going to give us 98. All right, moving on to the second one, I look at my operations and I see I've got subtraction, multiplication, and subtraction. So I will do my multiplication first. So when I do 12 times 5, it gives me 60. So now I'm looking at 4 minus 60 minus 30. I'm going to do my addition and subtraction from left to right. So 4 minus 60 is negative 56. And negative 56 minus 30 is negative 86. And a couple things that we talked about towards the end of class, right? So we've got the 0 power. So we said anything raised to the 0 power is 1, and we talked in detail about why. Now what am I going to do next? I'm going to do my exponent. So I'm going to do my negative 2 to the third, which is negative 8. I'm going to leave it in parentheses, and I'm going to bring everything else down exactly as is. So now I've got 17 to the 0, which I worked out to be 1, plus 15, plus 2 times negative 8. So I'm going to look at my multiplication and division from left to right. I only have multiplication, which is 2 times negative 8. Now I'd love to go down. I'm just a little, again, short on space there. So I'm going to just move it over a little bit. So 2 times negative 8 is negative 16. So now I've got 1 plus 15 is 16 plus negative 16 should give me a sum of 0. Now what we're going to do again is we're going to take that a little bit further. What happens when a number is next to a set of parentheses, right? So mathematicians, this is part of the language of algebra that was developed by mathematicians. The order of operations itself is kind of inherent in nature. It's not that we decided it. It's when the operations were kind of, I guess, discovered, you can say, it logically followed that the order of operations would have to be in that order. This is not necessarily that way. Mathematicians decided to use certain symbology, like a number next to a variable was a coefficient, and it was implied that there's multiplication, and the same thing here. This number next to an expression in parentheses needs to be multiplied. Now it's not going to be multiplied until we get to that point in the order of operations. So if I'm going through my order of operations, I need to do what's in parentheses. In order for me to do what's in parentheses, I have to, in my parentheses, use my order of operations. So I'm going to evaluate my exponent. So 5 squared is 25. Now I need to finish off what's in my parentheses, which is 5 plus 25, which is 30. And finally, I multiply 2 by 30, which gives us 60. Same thing, I need to multiply the value of that expression by 3, but I can't do that until I've evaluated everything in the parentheses, right? That parentheses, whatever's in it, that's still our first step in our 4-step order of operations, and then I'll do the multiplication at the end. So within my parentheses, I've got addition, subtraction, and my exponents, which I will do first. 3 to the third, also known as 3 cubed, right? So the second power is squared, the third power is cubed. 3 cubed is 3 times 3 times 3, which is 27. Bring everything else down. I'll do this one a little more step by step. So I've got addition and subtraction, which I'll work from left to right. 7 plus 27 is 34. 34 minus 30 is 4. And finally, we do our multiplication, where 3 times 4 is 12. All right, and we're going to kind of follow the same approach here, right? Negative 4 times that quantity. So I need to do what's in the parentheses. So within the parentheses, that's negative 4. I have 3 minus 3 squared. Now 3 squared is 9. So now in the parentheses I have 3 minus 9, which is negative 6. And then negative 4 times negative 6 gives us positive 24. So I would have written it, I guess I still could kind of squeeze it underneath here. I just kind of ran out of space. So again, when you're doing this in your notes, we'll follow the process of working down and not across, which we spoke about with the last lesson. This second one gets a little tricky here. So we need to do what's in the parentheses. Okay, well, that's easy over here, right? That's going to give us 16, so 5 times 16. And we can do this also, which is going to be -1. Now, we talked about this a little bit with the last lesson, right? What am I really doing? I'm really doing 5 times 16 and -3 times -1. And again, this is a subtle difference, but it's really important. Okay, so this is the way I want you to treat it. 5 times 16 is 80. Okay, -3 times -1 is +3. 80 plus 80 plus 3 is 83. Here's the way most of us would probably do it. 5 times 16 is 80. 3 times -1 is -3. Bring down the negative. Okay, what's 80 minus -3? Well, that's 83. What's the problem with doing it that way? Well, technically nothing, but there are a lot of mistakes that I see happen. One of those mistakes is we forget to bring this down. One of those mistakes is we do the -3 wrong, or we say, well, there shouldn't be 2 minuses, there should be 1. Really what we want to focus on going forward as we start to transition into algebra soon is that the sign of the number here tells us the sign of the term. So this is not really, a subtraction sign can mean a lot of things. It can mean subtraction sign, it can mean -1, it can mean negative, it can mean opposite. But really we want them to be tied to the numbers that follow them. So this is +5 times 16 is 80. -3 times -1 is +3. That's the way I want you to envision it. I don't really want you doing it like this because when we start solving and checking equations, it's going to lead to mistakes. So while it's something that probably seems very subtle now, you're going to say, well, I did it the green way and it was fine. That's fine. It will work out if you do it mathematically correctly, but it's going to lend itself to a lot of mistakes. And that's something I'm going to say multiple times during the year. All right, so when we have a fraction, it's implied that the numerator and denominator really both have parentheses. So my numerator is 12 times 3, which is 36. My denominator is 4 minus 10, which is -6. Now, what should I do next? Honestly, it doesn't really matter. Could you do 3 times 36 is 108 divided by -6 is -18? You could. Really, we should do what's in the parentheses, which is the division. 36 divided by -6 is -6, times 3 gives us -18. All right, so this is a big part of the lesson, which is using substitution. So we've got 4 different expressions. Now, the only difference in the expression is the placement of the exponent as well as the placement of the powers. The placement of the parentheses. So usually in class, I say, which of these will give us the largest value? And of course, it should be the last one because we're taking, in other words, what are we raising to a power in this one? Right? The answer is B. What are we raising to a power here? A. Not 4A, just A. What am I raising to the power here? The product of A and B. What am I raising to the power here? The product of 4A and B. Okay, so that's going to determine which of these is going to give us our largest and our smallest and so on. Now, when we're doing this, when we're substituting, okay, it should look exactly like this. All right, you need to substitute using parentheses, always, literally from today until whenever you're done with your college math. When you're doing substitution, you will always be using parentheses. Now, what do I do next? Well, you got to be very careful that we're always following our order of operations here. I have multiplication, and exponents, so I'm absolutely going to evaluate my exponent first. So 5 squared is 5 times 5, which is 25. And now I've just got multiplication, 4 times 2 times 5, so I can do that in one step, which should give me 200. Okay, let's move on over here. Again, I'm using the values from up here, just in case anyone didn't notice that. And again, what am I going to do first? I'm going to evaluate my exponent. 2 squared is 4. So now I've got 4 times 4 times 5, which is going to give us 80. Now in class, I would ask, why is the second one giving us a smaller result? And the answer is the second one has a squared, whereas the first one has b squared, and b is larger than a. Let's move on to the next one. I've got this 4, but then I've got ab in parentheses. And I'm going to be substituting for a and b using parentheses. I'm going to use brackets. So a is 2, b is 5, It's going to be squared. What's next? Well, I have to do what's in my parentheses. I got to figure that out first. This is the place that a lot of us are going to make some mistakes. What's next? Well, I see two things. I see multiplication and I see an exponent. I need to do the exponent first. So the exponent is going to be 10 squared, which is going to give us 100, times 4, which is going to give us a final product of 400. What about for the last one? Well, let's take a look. In my parentheses, I've got 4 times a, which is 2, times b, which is 5, and that whole thing is going to be squared. So I can do everything in my parentheses right now. 4 times 2 times 5, really we should do 5 times 2 is 10 times 4 is 40 squared, which is 1600. So just altering the placement of your parentheses and your exponents can obviously yield very different results when evaluating what seems like a very simple expression. All right, so something else we need to talk about is what happens when we raise a negative number to a power, right? So if you've ever made this mistake, you put something, your teacher asks you, what's negative 5 squared? And you think you're slick, you put it in your calculator and you say negative 25. And the teacher says no, and you say, well, I used my calculator. And they said, you did, but you used it incorrectly. Negative 5 squared is negative 5 times negative 5. And we multiply two negative expressions, the result is positive. Now, why is it that negative 5 without the parentheses squared is negative 25? Well, there's a few different ways we can think about it. So we can think about this as, this is the opposite of 5 squared. So I'm not doing negative 5 times negative 5. I'm doing 5 times 5, and then I'm taking the opposite of that. So 5 times 5 is 5 squared is 25, and then I take the opposite of that, which is negative 25. Another way we could think about it is, some teachers say the negative is not being squared. That's technically true. Another way we can think about it is, negative 5 squared is really, it's the opposite of 5 squared. Now the opposite is negative 1. This is really negative 1 times 5 squared, or the opposite of 5 squared. So what's 5 squared? 25. What's the opposite of that? It's negative 25. Is this vastly important in the grand scheme of things? If you're a little confused right now, it's not, but it's something that comes up here and there, and it's something that we're going to see when we check equations also. So I'm trying to cover some of those bases of the mistakes that I feel like we may make in the future preemptively. All right, so let's talk about applying what we just did here. Right, so the first one says negative 2 times 5 minus 8 squared, which is pretty similar to one of the ones that we did before. I'll do it down here. 5 minus 8 is negative 3. We do our exponents next, so negative 3 squared is negative 3 times negative 3, which is positive 9. And negative 2 times positive 9 is negative 18. All right, for the next one, I'm going to evaluate for the sake of what we're doing here, right? So this is 3, 2 plus 4 cubed, which is 64. And then I have minus 6 times 5 minus 8, which is negative 3. I'm going to rewrite this on top. So I've got 3. I'll do the 2 plus 64 is 66. Negative 6 times negative 3. Now this is one of those guys where I'm going to really reinforce what I was talking about earlier. This is 3 times 66. This is negative 6 times negative 3. I really don't want to see double signs. So 3 times 66 is going to be 198. Negative 6 times negative 3 is positive 18. And that's going to give me 216. Believe me, that's a lot easier than saying 198 minus negative 18. All right, I'm going to erase some of this so I can move on here. Let's take a look at the fraction. So I've got negative 5. And then in my fraction, 15 times 6 is 90. 5 minus 20 is negative 15. 90 divided by negative 15 is negative 6. Negative 5 times negative 6 is 30. And let's recap the last thing we did prior to this. Negative 3 squared is negative 3 times negative 3, which is positive 9. Whereas the opposite of 3 squared is the opposite of 9, which is negative 9. Okay? All right, guys, homework is just these 6. Make sure you notice that there are some, that is a decimal, and that is a decimal, in case you thought it was a little smudge on your screen or something like that. We see the 0 power over there in number 2. And again, I don't want I don't want answers, right? 17:1. I want you to show the steps exactly like we did in class. Write out the full question. You work below it, right? You work down, not across, just like we've done in class now for 2 days. And as always, guys, any questions, best thing to do your best, take the photo, submit it. Either write me a little note on the homework or do that and write me a little note on the side on Google Classroom. You can also shoot me an email, and we'll talk about it, and we'll talk about maybe meeting up at office hours also.